Welcome to the deep dive. Today we're venturing into the twilight world of a creature that, well, it almost defies description. Imagine something. Is it a squirrel? Maybe a bird? Or, I don't know, some kind of living kite?
Yeah, it really stuns people. We were talking about the Colugo. It's this vegetarian night stalker from Southeast Asia. And honestly, probably one of the strangest mammals you've maybe never even heard of.
Exactly. When you first encounter it, the confusion is immediate. People call it the flying lemur.
Right. Which is catchy, but completely wrong. It's not a lemur. And it doesn't technically fly. It glides.
So it's this evolutionary puzzle piece, sits in this weird, almost primate, uncanny valley. Our mission today, really, is to understand how this creature built its entire life around, essentially, specialized air travel.
That's the core of it.
Yeah.
We need to unpack these really extreme adaptations. The gliding is spectacular, obviously, but there's so much more. We'll get into things like his weird comb teeth, how incredibly light it is. Just fascinating stuff.
How light are we talking?
We'll get this maybe 1.5 pounds, sometimes a bit more. But think about it. That's like 5 times lighter than an average human head.
Wow. Okay.
And that lightness isn't just a random fact. It's absolutely fundamental to how it survives. It has to be that light to use that skin membrane for travel.
Let's go back to that flying lemur name, because the classification is key here. It's misleading, but maybe not wildly off in terms of general weirdness.
Maybe. It does have that sort of wide-eyed look. Some sources even described it pretty vividly as the mutant love child of a tarsier and a flying squirrel.
That paints a picture.
It does, but the genetics tell an even more incredible story.
Huh.
You see other gliders, right? Flying squirrels, sugar gliders. They glide, eat fruits, nuts, avoid predators on the ground. Similar lifestyle.
Makes sense.
But the Colugo's lineage, it's completely different. Those DNA tests we looked at, they confirmed Colugos are actually the closest living relatives outside of the primate order, our closest non-primate cousins.
Wait, our closest relatives outside primates? That's hard to picture looking at it.
It is. But you have to remember the time scale here. This isn't a recent split. We're talking about an evolutionary divergence way back in the Cretaceous period.
Cretaceous. So, dinosaurs.
Exactly. Over 65 million years ago, dinosaurs were still the dominant predators, hunting these tiny early mammals. That's an immense amount of time for these two lines to adapt and change independently.
Okay, that context changes things. It highlights how long they've been perfecting this gliding strategy.
And gliding itself must be a really successful strategy, evolutionarily speaking.
Yeah, you see it pop up independently. Rodents did it. Marsupials did it.
And now these colugos,
Yeah.
all converging on the same solution. Avoid the dangerous ground, travel through the air. But the Colugo's way is unique.
And despite all that evolutionary time, only 2 species are left today, right?
That's right. 2 distinct species.
First, there's the Philippine colugo. This one's the biggest, can get up to maybe 1.5 kilos. It's got this mottled coat, a wider face. I saw one description call them the pit bulls of the colugos. Kind of stocky looking.
Yeah. You find those mainly in the southern Philippines, Mindanao, Bohol, islands like that.
Okay, and the other?
That's the Sunda Colugo. It's got a much bigger range across mainland, Southeast Asia, Thailand, down through Malaysia, Indonesia. These are generally smaller, sleeker, solid brown, or maybe a ginger coat, more delicate face. The Colugo greyhounds, maybe.
Pit bulls and greyhounds. But regardless of the look, their entire existence revolves around mastering the air, doesn't it?
Absolutely. It's all about the glide.
So let's talk about that. The physics, the
Yeah.
equipment they use. How do they do it?
Well, think about being that small. The forest floor is just swarming with dangers. Small cats, foxes, toles, those are Asiatic wild dogs. Constant threat.
Right, so the air is safer.
Much safer. And to maximize that safety, they need maximum surface area for gliding. That's where the patagium comes in.
The patagium, that's the technical term for their built-in kite.
Exactly.
Yeah.
It's this incredible membrane of leathery skin. It stretches from their wrists, down their sides, all the way to their ankles, even between their fingers and toes, and connecting to the tail.
So it covers almost everything. Maximum possible surface area without actually being a batwing.
Precisely. They are basically living hang gliders. They climb as high as they can on one tree and launch.
And how far can they go?
It varies. Routine jumps might just be 20 or 30 meters, treetop to treetop, but they've actually been recorded gliding up to 200 meters.
200 meters! That's astonishing.
It is. But here's the crucial trade-off. Because their body is so perfectly engineered for that parachute shape, they are terrible walkers. Just awful.
So if they land on the ground,
It's incredibly risky. They're clumsy, slow, completely exposed. Their whole survival strategy depends on staying arboreal, climbing, and gliding. Falling can easily be fatal.
Okay, launching is one thing, but landing. After a 200-meter glide, hitting a vertical tree trunk seems incredibly difficult. How do they manage that?
This is where it gets really sophisticated. They talk about this gyroscope landing system.
A gyroscope. Sounds almost
Well,
mechanical.
it's biological engineering, honed by millions of years. When they glide, they maintain an almost perfectly horizontal path, losing very little altitude over distance.
Okay.
But as they get close to their target tree, they have to do something really clever. They basically swivel their entire body upwards, pulling up like an airplane flaring for landing.
Ah, so they changed their angle.
Exactly. And that upward swivel does two critical things. First, it dramatically increases air resistance, acting like an air brake. It slows down their forward speed, that x-axis velocity.
Makes sense.
But at the same time, slowing down that forward speed makes them drop faster vertically, the y-axis. So they need absolutely perfect timing, decelerate just enough at just the right moment to stall slightly and grab onto the vertical tree trunk without tumbling down to the forest floor. It's incredibly precise.
Wow. And they're doing this complex aerodynamic maneuver in the middle of the night.
In pitch darkness. Which brings us to how they navigate this nocturnal world. Imagine launching yourself into what must feel like a void, relying entirely on vision and instinct to hit a tiny target maybe dozens of meters away.
That takes some serious sensory equipment.
Absolutely. And they have it. Huge eyes, packed with giant retinas. This gives them excellent night vision, crucial for seeing in low light, and importantly, great depth perception. You need that to judge distances accurately for those long leaps.
Being nocturnal also helps them avoid certain predators, I imagine.
Definitely. Their biggest aerial threat in places like the Philippines is the Philippine eagle, a massive bird of prey, but it hunts during the day. So being active at night gives colugos a significant advantage against that particular danger.
Okay, so great night vision, great depth perception, but I read something really surprising about their vision. Color.
Yeah, isn't that weird? Despite being strictly nocturnal, there's evidence suggesting they might have some form of color vision.
Yeah.
Well, the theory is that it might have evolved independently, convergently, like it did in primates for a very specific reason. Spotting ripe fruit. Being able to distinguish colors could help them pick out the best, most nutritious fruits from a distance, even in dim light.
That's fascinating. Convergent evolution for finding snacks.
Pretty much. And their diet requires a specialized toolkit beyond just good eyes. It's very high in fiber.
What are they eating mostly?
Their favorites seem to be soft fruits, like fruit salads. But food isn't always available. So they supplement that with tougher stuff, young leaves, tree bark, flowers, even lichens scraped off trees, sometimes ants, maybe for extra minerals.
Bark and lichens sound tough to eat.
They are. And that's where another unique adaptation comes in, their teeth. Specifically, their lower incisors.
Cone teeth.
Exactly. They're shaped just like tiny, intricate combs, and they have this brilliant dual purpose.
Okay, what's purpose number one?
Nutrition. Those comb teeth are perfect for scraping. They can strip away tough lichens from bark or peel tough skins off certain fruits, getting access to the food underneath.
Now number two.
Grooming. Those same comb teeth act as an incredibly efficient brush. They meticulously groom their fur, removing dirt, debris, and crucially, picks and other parasites.
Ah, so hygiene is vital too.
Extremely vital, because unfortunately, one consequence of their specialized high-fiber, plant-heavy diet is that they tend to carry a really high parasitic load.
Oh.
Yeah, well, there's a rather striking detail mentioned in some accounts. Apparently, their feces have sometimes been observed to move due to the sheer number of internal worms passing through.
Wow. Okay, that's vivid. Really underscores the challenges they face just staying healthy.
It absolutely does. Everything about their existence is specialized and comes with these high-stakes trade-offs. Which leads us logically to thinking about the next generation. How do you raise young when you live like this?
Right. You can't exactly leave a baby in a nest when your whole life is about jumping between trees and predators are everywhere.
No way. A static nest would be far too dangerous. So the mother colugo has evolved this really clever, almost marsupial-like approach to parenting.
Marsupial-like? How so?
The babies are born quite underdeveloped, tiny. They immediately crawl under the mother's belly and latch on.
Okay.
And then this is the ingenious part. The mother uses her tail, which is also part of the patagium membrane, to curl upwards and forwards, creating a sort of fleshy hammock or pocket against her belly.
A pseudo-pouch.
Exactly, a built-in baby carrier. She carries the infant tucked in there for months while she forages, leaks, and glides. The baby just hangs on. She slowly introduces solid food as it grows. It's constant, direct care, driven entirely by the dangers of their environment.
That's incredible maternal dedication. So we've talked about predators on the ground, eagles in the air. What's their situation now, conservation-wise?
Well, officially, both species are currently listed as least concern, mostly because they still have relatively large ranges across Southeast Asia.
That sounds good. But is there a but?
There's definitely a but. The underlying threat is significant, and it's growing. The main problem is deforestation, habitat loss,
Fewer trees.
fewer trees, and critically, the trees that remain are becoming more spread out. For an animal that relies entirely on gliding specific distances, suddenly finding the next tree is too far away. That's catastrophic.
They can't just glide further.
There are limits. And bigger gaps mean they might have to risk landing on the ground, where they're vulnerable. Plus, new roads cut through forests, fragmenting the habitat even more. If they misjudge a glide and land on a road, well, the outcome isn't good.
So if the gaps are getting too wide, what can be done? You can't exactly teach a colugo to use a bridge.
No, but conservationists have come up with a pretty innovative solution that respects their biology. They're building artificial gliding posts.
Gliding posts. What are they?
Essentially, they're just tall poles, like utility poles, strategically placed in areas where the forest has become fragmented, maybe in the middle of a logged area or alongside a road.
Ah, I see. So they act like intermediate stepping stones.
Exactly. They shorten the required glide distance between remaining trees. They give the colugos a safe landing spot mid-journey, allowing them to cross these increasingly wide gaps without having to risk the ground. It helps maintain connectivity in the population.
That's a really clever way to mitigate the impact of habitat loss, working with their natural behavior instead of against it.
It really is. It acknowledges just how specialized they are. You have to support their aerial lifestyle.
So wrapping this up, the colugo really is just a masterpiece of specialization, isn't it? Everything about it, that patagium kite, the incredible gyroscope landing, even those bizarre comb teeth, it's all laser focused on one evolutionary mission: master the air, avoid the dangers below.
Absolutely. And if you look at it from that broader evolutionary perspective, it's such a powerful example of how intense environmental pressures, like constant predation pressure from carnivores, can drive these incredibly dramatic, complex adaptations. They didn't just adapt to gliding. They optimized literally every part of their being for it. It's extreme evolution in action.
So here's a final thought for you, something to mull over. We're now seeing conservation efforts involve building these artificial gliding posts. Humans are literally adding infrastructure to the Colugo's environment to help them survive habitat fragmentation. Given this increasing reliance on human-made structures, what might happen next? Could we eventually see subtle new behavioral adaptations, maybe even physical changes in colugo populations as they learn to navigate this modified canopy? What does the long-term future really hold for such an incredibly specialized glider in a world that keeps changing around them?